Yo, what is up? Happy Saturday. It is time for another Plebdevs workshop. I'm excited for this one. I've been throwing this together the last 2 days. Obviously with MutinyNet now and Voltage, it's actually becoming easier and easier for me to make workshops and build Lightning apps quicker. So I'm super excited about that. Let me quickly, I'm gonna update some of my notes here so people know what's going on, and I'm gonna make sure that you can see the link to get into the slides. So let me, tinyurl.coms. Let me just get this to fit. Okay, there we go. That barely fits. Let me put it in. I'm going to put in the scrolling text here. And we'll get started in just a second here. Join along at https. MutinyNet. Okay, sweet. That should be good. Cool. All right, what is up? Let's get into this now. So, build a Lightning app with Voltage and MutinyNet. I find myself again and again showing people easier ways to build their first Lightning app, or I guess different ways, different considerations, and just trying to give you the opportunity to get the reps in and get lots of experience interacting as an app developer with your Lightning node, right? And now with Voltage and MutinyNet and Voltage's free MutinyNet nodes, this is becoming easier than ever. And in fact, this is changing really how I'm going to be doing a lot of my workshops that involve Lightning from now on. We had to do a lot of tricks in the past to do things like maybe running a local Lightning node in RegTest, right? So a local test network. And it's like, okay, cool, we have this local Lightning node, but if we have an app that needs to talk to that Lightning node over the global network and not just local network, we have to do tricks like use ngrok or something like that. So my process for setting up the Lightning node was always just not as simple as I wanted it to be, especially for the new people, because that is one of the hardest steps with actually building a Lightning app is getting your developer environment set up. And so I'm gonna walk you through that, and yeah, let's just jump right into it here. So links, obviously I shared the links to the slides. That's in the scrolling text. I need to format that better actually. Cool. You can see it there. You can see it on the agenda on the side. So these slides are gonna have, you know, all my explanations, a few screenshots, but most importantly, it will have the other links and some code, and we will be putting in code later on. So kind of the first half of this workshop, we're just gonna be talking about MutinyNet, talking about Voltage, getting our nodes set up, and just talking about the considerations around that setup process before, I guess, you would start writing code. But the second half of the workshop, we're gonna be writing code and really putting in code slide by slide. So I was trying to clean it up a little bit. So there's a lot of code here, but it's all very similar and actually pretty simple. But by the end of this, we'll have a pretty cool Lightning app that is going to interact with our MutinyNet node. And hopefully I'm actually going to get more than one MutinyNet node up and get them connected to each other. So that should be fun. So these are the links. You'll find them in the second slide. And let's actually look at the completed project. So this is what we're going to build today. Let me make a little bit of room here. We're going to be doing this on Replit. Really been loving Replit lately. So I'm going to start up this app and I'll open it in a new tab. I think I opened it too earlier. Okay, here we go. Open it in a new tab. Cool. So Lightning Node dashboard, connect to your node. So we don't see anything yet. I'll show you what this will look like though, because I actually have, this is my MutinyNet node that I had already set up beforehand. So I can grab a few basic pieces of info here. My API endpoint, first and foremost. So that will be our host at https://. Yep. Our port is going to be 8080. And then I'm going to grab macaroon. And for once, I'm not nervous going through these pages since this is not real Bitcoin we're working with today. It's all development. Put in the macaroon, connect, and there we go. And we're going to have a dashboard kind of like this where we're seeing all of our balances. We're seeing our inbound or outbound information about my node. I've got a little Lightning wallet here, and then I can see my peers and my channels. I know it's not that pretty, but it's something I threw together. And so we also see the block height up here, and we hit this refresh button and we can kind of refresh the state of everything. So that's what we're going to build today from scratch, and I'll go through it from scratch along with you. But of course we have the completed project here, so if you want to just skip to the fun stuff and go take that code, you can do it. Great. So overview, we're going to talk about what is Voltage. We're going to talk about what is MutinyNet. We're going to set up a new Voltage MutinyNet node for free. We're going to build a front-end app on Replit to interact with our MutinyNet node. And then we're going to move sats at the speed of lightning, hopefully, if things go right. Sweet. So what is Voltage? I mean, I've talked about Voltage a ton in my Plebdevs videos. It is a platform for deploying Bitcoin infrastructure. Really what this means as a dev is it's a place to spin up a Bitcoin node, to spin up a Lightning node, or multiple of them. And then it solves a lot of problems around managing that node and interacting with it. And so I taught Voltage specifically in the second Plebdevs course, which you can find at plebdevs.com. And we actually, we built a full stack Lightning app. And when we were in development, we were using kind of a local fake Lightning node. But once we moved into production, we used Voltage to deploy our production Lightning node for our app. And so that was a pretty cool experience. And so traditionally, Voltage for me has been an option for deploying my, production Lightning node. It's the thing that I deploy after I've already developed the app. But now with Mutiny node, we will actually be developing the apps with Voltage as well in the development stage, which is cool. So that's what Voltage is. So just a little bit about a typical full stack Lightning app. Like what is this? What are the pieces that go into it? And it can look different depending on what you're building. But this is maybe a generic example. You've got a front end app. This is the UX. This is the UI. You'll have an API, which is just the interface in which all the information is communicating through. And then on the back-end side, you'll have a Lightning node and a database. Maybe you don't need a database depending on what your app is doing. But if you're interacting with Lightning, you most likely need a Lightning node unless you're using someone else's. And of course, that Lightning node is our gateway to the rest of the Lightning network. And so typically this portion of the Lightning node, this has been pretty hard. Pretty hard to set it up in development and develop with it. But then also when you're moving to production, you're trying to release your app for users, things are a lot different if you're, with a local reg test Lightning app, and then you're moving it into production. So it's kind of a scary process. This is kind of the typical full stack app. And so common hurdles to building your first Lightning app. These are the main ones I found and that I hear over and over again from developers. So we have running a node, hosting and maintaining that node, setting it up at the first place. That can be a lot. We've got talking to your node, which, that's just what I call it, is talking to your node, but really it's just like, how are you interfacing with your node? How are you making your node move money or create invoices or whatever you're doing with your application's code? And that can be a little bit difficult, especially for newer developers. And then, of course, developing with a node, like, what is this development process going to look like? How do I actually simulate things or replicate what might happen in my production app? You almost need multiple fake nodes in a local network to even do it, which we have done many times. And then getting liquidity is another one. And this is just kind of the idea of, Lightning nodes having channels, and that those channels give you outbound if you open a channel to someone, or inbound if someone opens a channel to you. And then, of course, the outbound and the inbound shifts as you are routing transactions. I talk about this in more detail in my workshop, Building Your First Lightning App, so check that out on YouTube if some of this is a little bit over your head. But yeah, getting liquidity is just this problem that Voltage helps us solve, and it's something that's traditionally been pretty difficult because you need a friend to open a channel to you or something like that, or a service, and you have to pay for it. And so Voltage helps with all of these hurdles right here. This is literally just a list of Voltage's products, but they have the nodes, and the nodes help with, obviously, this running a node, hosting, maintaining. They make it as easy as clicking a few buttons. And of course, you have full control of your node. It's encrypted with your own private key. And then Voltage, their nodes product, it helps talking to your node as well, because it gives you the interface to talk to your node in a very simple way, and gives you all the connection information that you need. So you don't have to go into the command line and run a bunch of commands to even get the connection interface to connect with your node. And now with MutinyNet, developing with a node is a lot easier with Voltage, right? So they have BTC Pay Server here, obviously an amazing product. It's something that, a lot of people probably use their Voltage nodes for. So Flow is a way to access liquidity and to automate liquidity. And so that solves another one of our big problems as a Lightning developer. When we're in development, we don't really have to worry about that. But if we ever want to scale up and serve real users, we're going to need Lightning channels. We're going to need inbound liquidity. And we've got Surge that will help you with further node analytics and stuff like that. And of course, they've got enterprise and Nostr features as well. So Voltage is really becoming like an all-in-one platform for me as a dev, building stuff on Nostr and Lightning and Bitcoin. They're just satisfying more and more of my use cases. Okay, so I've said MutinyNet a bunch of times already, but what is Mutiny? What am I even referring to? So let's talk about the different Bitcoin networks. So Bitcoin has several networks designed for different purposes, allowing developers, testers, and users to experiment with transactions without risking real money or affecting the main Bitcoin blockchain. So here's a brief description of each one. So we got mainnet, testnet, regtest, and signet. So mainnet is the Bitcoin that we know and love. It is the real Bitcoin. It's the one that you're running a node for it at home. It's on mainnet, and obviously that's where all the consequences are the most real, on mainnet. We have testnet though, which is an alternative Bitcoin blockchain used for testing. Testnet coins are separate and distinct from actual Bitcoins. They're never supposed to have any value. This allows application developers or Bitcoin testers to experiment without having to use real Bitcoins. So cool, testnet, that's nice. We've got regtest, which stands for regression test mode. This is what I often use in my workshops. So this is a local testing environment where developers can control block generation and create an almost instant private blockchain for testing purposes. So you get to create the whole network, right, with regtest. And then we got Signet here. Signet, a relatively newer network that is like testnet, but with a twist. Signet is a test network that uses signed blocks, which means it has more reliable block times compared to testnet. So testnet actually uses proof of work. So you can actually take your S9 miner and you can go mine on testnet for testnet coins. But regtest, local and fake, it does not have any idea of mining, and neither does Signet. Signet is like, just forget about the mining. We just want an open test network that has more consistent block production. We don't have to worry about mining blocks. So this is my short summary of each. Mainnet is global and real. Testnet is global and fake. RegTest is local and fake. And Signet, like Testnet, is also global and fake, right? So it's just the idea of like with Signet, with Testnet, we are actually in a global network, but we're just trading fake Bitcoins, right? For testing and stuff like that. Okay, and that moves us into what is MutinyNet. This is a cool picture from their website. And this is a description of why MutinyNet from their blog post. So there are several key reasons we decided to create MutinyNet. So simplified testing infrastructure. We wanted a simple test network with all the infrastructure already up and running to make it easier for us to test new features. Faster block times. The default Signet block time of 10 minutes can slow down testing. So we've cut this down to 30 seconds. So I guess first of all, MutinyNet is a Signet. It is a type of Signet. But it's a type of Signet that is so optimized for developers. A lot of people are using this Signet instead of the usual testnet. I know it's so confusing, right? It's so confusing, but MutinyNet is just, it's a better testnet. And then now that Voltage gives us access to this for free, it is the best place to kind of develop our Lightning apps, right? So we have faster block times. So MutinyNet blocks are 30 seconds. Testing over time. So a Lightning channel isn't just a one-shot thing. It's a long-term, stateful, romantic relationship between two nodes. Plenty can go wrong, and by creating long-lived Lightning channels between Mutiny Wallet and other nodes on MutinyNet, we can make sure it's battle-hardened, right? So testing over time. And that's kind of something that we have here. We might have an application in development, and maybe we shut the laptop at the end of the day, but those Mutiny nodes, even though they're for development, they're still up there running. Right? So you get a real simulation, more of a full scope simulation of what your application or your Lightning node might be doing in production on the real mainnet. So custom signets are cool. Everyone is setting up their own signets these days. We wanted to join the party and add our own block time twist. Why let Plebnet all have all the fun? Yeah, so people, because of some of the issues of testnet, just inconsistency and slow blocks sometimes, developers more and more have been making their own signets for their own use cases. And MutinyNet just happens to be a signet that's super useful for a lot of people's use cases. Okay, so let's set up a new MutinyNet node on Voltage. So we're gonna do this up front because it might take about 15 minutes for this to actually spin up. All we have to do is click a few buttons, but since MutinyNet, it has a block height, our new node is gonna have to sync to the current block height, just kind of like when you set up a new Bitcoin node. So you can go to voltage.cloud here and find Voltage, and you will need to sign up, but you can do it for free with only an email. And I'm already logged in and signed up over here, as you saw. And so let's go back home, all teams. So I have my mainnet node here, Bitcoin Plebdev, and then I already have a MutinyNet node here called Plebdevs, okay? But you're starting out, you won't have a MutinyNet node yet. So we can create a new instance. But actually, Voltage lets you have, I believe, up to 3 MutinyNet nodes for free. So I'm gonna add a second node. I'm gonna start it up from scratch, just like you will back at home. So we're gonna click new instance here. And I have this also in the screenshot. Yep. These are the 3 steps you'll go through. We click new instance. Let me make sure I'm zoomed in for you all. And I'm gonna choose Lightning node. And then right down here, I'm gonna choose MutinyNet. And we see it has the free tag right here. I've got some warnings about my billing, but don't worry, I think it's just a bug. Okay, let's hit continue. Cool, now it wants a name. Oh man, what should we name this? My other one is called Plebdevs. I'm just gonna name it Austin. That'll work. And we're gonna choose a password here. I'll just do a password, quick password. And this is what will actually encrypt our node so that we have full control and Voltage is not gonna be able to rug us in our sleep. Okay, so my node's name is gonna be Austin. I'm gonna hit create. Node created successfully. Okay, so it is now spinning up my node, and it'll take a few moments, really more like a few minutes, but that's cool. So we got that running. Be sure to just get that spun up on your side, because like I said, it'll take about 10-15 minutes, something like that. But cool, we are working here. Okay, our MutinyNet node is spinning up. So in the meantime, let's build our front-end app with React and Replit and start to get into that portion. So first of all, you're going to want to set up a new React Replit app and install Axios. If you've never been to Replit, I'm starting to use it more and more. I'll just go home here. And so you can create an account for free. And when you're logged in, you'll see a page like this. And just so you know, Replit, it's just a coding environment in the browser. It just makes it easy to have kind of spin up a new project and just start writing code versus me showing you locally install this and do this. And so we can simply create a REPL right here. We can choose React JavaScript, and it'll give you a random name here. Or you can just choose, choose your own. And I'll create this REPL. And you'll be presented with something like this. It'll boot up, and you'll have kind of a boilerplate app here. Yeah, and the first thing you're going to want to do is jump over to the shell, and we're going to say npm I Axios. And this is just going to be, I think, the one single library that we need to use in this front end. Even though this front end is going to be a whole Lightning app, this is just the one library. So go ahead and npm I Axios, and we'll install Axios, which is just a library for making HTTP calls. So it's the library that we'll use to talk to our Lightning node once it's fully spun up. Yeah, and so I'm back over here. We can see it's syncing with the chain. So yeah, about 10 minutes. So that's good. So I have my new Lightning app spun up here. I did npm I Axios, and I installed Axios. At this point, you can hit run, and you'll see it'll kind of open up a little web view here, and just kind of a little hello world app. So that's cool. But next, we're going to start putting in code. And all the code is going to be here in a bunch of different slides. And we're going to put it in step by step. And I'll put it in along with you, and I will explain what all of this code is doing. Okay, so we're going to start inside of app.js, which is our app component. And we're first going to set aside some state in our app component. So let's just copy this, and I'll kind of tell you what we're going to be doing with this. I'm going to close this out. This is just the completed project. Okay, so I've got this app component here, and I'm just going to paste all of this. Okay, and what is this? So we're importing React use state and use effect, and then we're importing Axios from Axios. All right, and so all of these are just use state. So what is this? This is all of the data, basically all of the data that our app is going to be expecting to hold on to and to update, right? So use state gives you a value, which is whatever the state is, and then it gives you a function to set that state. So that's all we're doing. So we're going to have channels, but then we're going to set those channels. We're going to have to get the channels from our Lightning node and stuff like that. So, okay, at first, just throwing in our state here. Am I zoomed in enough? Let me zoom in a little bit more for you. Cool. So next slide, we're going to add in our connect and get info functions. And this is going to go in right below our state. So let's paste this in, and I'm going to walk you through it. Okay, so we have a function here, connect to node. And this function is going to be our first one that's attempting to talk to our node, right? So we're going to take in certain bits of data, a host, a port, and then a macaroon, which is going to be our authentication. And at first, we're just going to get info from our node. And we're going to set, if we do get that info, we're going to set it to connected node. Otherwise, we catch any errors that we get, and we just kind of let the user know that they got an error. So we've got this connect to node. I've got this connect function, which connects to node, takes away the form. We're gonna have load all. It's not there yet. And then I have a get info function, right? And this right here, so above all of the functions where I am gonna be interacting with the API, I'm gonna give you a link to that exact API method in the LND docs, right? So this is the Lightning, the LND, what does that stand for? Lightning Network daemon docs. And most of the commands that you're gonna wanna be looking for are inside of the Lightning service here. So I can open up Lightning service and I see all of these different methods, these different ways that I can talk to my node and make requests to them. Looking up a new invoice, creating a new address, open channel, right? So all of these are in here and they're highly specified. There's a lot of information about all the different things you can do and some code examples as well. But I think my code here will serve as just the most simple, bare bones way that you can call the LND API, right? So we have a try catch here. This is to catch any errors or to try and make a request. We simply use Axios to get the info from our node. We pass in the macaroon, and we have to do that to authenticate that this is actually our node. And then we set it. Okay, so that's how a lot of our functions are going to look here. They're going to look very similar. So let's continue on. We're going to add in a load channels function. Let's copy this. And I'll put this below get info. We're just going to keep on going down the line. So load channels, once again, I'm pointing you to the LND method where you can learn more about this. But very similarly, we are, I guess we're making an options object first, but we're still just calling axios.get for v1/channels, right? We get our channels, we set our channels, and from here, there's a little bit of a calculation. We calculate the total inbound and outbound from our channels, which currently we have no channels, so it will show nothing. But yeah. So that is load channels. And then we're gonna load channel balances. So this is gonna get our actual Lightning balance. And we'll continue, we'll drop it down below. There we go. Once again with the link for you. So you can see it looks very similar. Just getting the data, making sure we do, and then setting it to the right state. And if there's an error, we alert. All right. And then finally, we're going to add in our load on-chain balance function to see our on-chain balance. Because a Lightning node does not only have a Lightning balance, you have an on-chain wallet inside of there as well. So very similar. Here's the method. We go to balance/blockchain, get the response, set it to on-chain balance. Pretty simple. Okay. And then we're going to have a load all function to load all the data in one call. And this is actually what our refresh button that I showed you earlier will be hitting this. And the refresh, it'll just grab all this data and it'll refresh, to the latest state. Okay, one more piece of code and then we'll start to test things out, or basically our return and then our CSS. So this is the first part of our return in app.jsx. So I'm just going to paste this in right here. And then that's part one. We'll go to part two. And there we go. Yeah, and then we need to close the function with a curly bracket and then say export default app. So sorry if I missed that. Okay. So there we go. We got our return, we've got our functions, and we've got our state and our imports. So that is app.jsx. But next we're going to put in some styles here. I know this is super small, but we'll just go into app.css. We'll paste in the first slide. We'll paste in the second slide, and I think there might be one more slide of styles. You know, just so we start with something pretty. Of course, I highly encourage you to update it and make it your own. Next. Oh yeah, that was it. Okay, so that's all of our CSS. So let's save it. Okay, we just pasted in a bunch of code. But let's actually check this out and see what we've got so far. So I'm gonna hit run. And I'm just gonna go ahead and open this up in a new tab. I can do that with this button right here. And it'll open up a new tab. Sweet. So this is what we're starting with. This is app.jsx. It says not connected, and then we got this button to connect to our node. And it's asking us for 3 pieces of information: host, port, and macaroon. And so the host is just where your Lightning node is. It's a URL. The port is which port on that URL you need to access, which it's going to be 8080 for us every single time, because this is the default port for L&D to talk to their REST interface, which is what we're making our API calls to. Okay, so it looks pretty good. So let's connect to our node. We're at this point, and we need to put in our host, our port, and our macaroon. Okay, so let's jump back over to Voltage, and let's see where we're at. It looks like we're up and running. Your node is online and running. It looks like we're caught up to the latest block, so we should be able to connect. So the connection information that we need is the host, the port, and the macaroon. So the host, you can find right here, API endpoint. And then we see the REST port right here, like I was saying before. So I'm gonna copy this API endpoint and put it into our app, but we're gonna need to put HTTPS : / at the beginning. Let me zoom, I'm gonna zoom way in, okay. So you can see that. So we are gonna need to put that at the beginning so we have a proper URL, and then I'll just paste the rest. And so this is the URL of my Voltage node. It's actually pretty short. I guess I'm the only MutinyNet node with the name Austin. So that's kind of cool. And next, we need to grab the macaroon, but where do we grab the macaroon from? So we're here on the home page with our new MutinyNet node. We can go into this side tab here, Manage Access, and open it up. And there's this tab called the Macaroon Bakery. And so what is a macaroon? A macaroon is just an authentication token for L&D specifically. So we can have different kinds of macaroons, like an invoice macaroon will let anyone that has it request invoices from us. So that means they can pay us, but they can't take our money, right? They can't spend our money. They can only pay us, right? So that's an example of an invoice macaroon. But here we're gonna have an admin macaroon because it has admin level permissions, which means they can send us money, they can spend our money, they can open new channels, they can do everything with our node. So normally you wanna be super careful with your admin macaroon, but this is just our MutinyNet node. We're gonna move fast and reckless, and I'm gonna copy the hex right here of this macaroon, and we're just gonna throw it into this sketchy web app that we just built, and we're gonna see if it works. So that'll be the final piece here, the macaroon. It's this big hex string. And we'll hit connect. And there we go. We are connected to our node, connected to Austin, so it has my node's alias, and this is my node's pub key. And we see on-chain balance, total inbound, total outbound, and obviously it's all 0. And I've got the block height up here, which is changing every 30 seconds. And if I hit the refresh button, yeah, I can see we went up a block. If I hit it again, we're not quite at the next block, but yeah, every 30 seconds we'll be in a new block. Cool. So we're at a pretty cool point with our MutinyNet node here. Let's go back to home. Okay, so we know how to get the API endpoint, the port, and the macaroon, and we'll probably do that a little bit later. Okay, so what am I gonna have us do next? We're connected. Your balances will be 0 though. Yeah, so this was a screenshot from my other node, Plebdevs. But cool, so we are connected. So let's get some on-chain balance and a channel. So we can do that right here. We can say get MutinyNet coins, and then we can open channels. So let's get MutinyNet coins. And we can choose a certain amount here. Let's go for 10 million, because, like, you know, why not? Let's get 10 million sats on chain from MutinyNet. Okay, your coin should arrive within the next 30 seconds. Okay, let's refresh our app. Refresh. Boom. That fast. Look at that. So we already have an on-chain balance now. And Voltage made that super easy, right? So we didn't need to go to some stupid testnet faucet or anything like that. We're able to get it just right inside of here. Great. So now the next thing we can do is get a channel. So let's select open channel. We'll do 1 million sats. That's fine. And then we can choose an amount to push. To basically, we can open the channel and then push them some sats. So let's go ahead and do that. Let's push them 10% of our 1 million sat channel. And we'll open that up and we should see it pretty soon. So let's refresh. New block height. Yeah, and this might take a second. Yeah, and it'll update over here as well because it tells us confirmed on chain. That's actually wrong. Let's refresh. Refresh, I need to unlock. Okay, cool. Now I have a confirmed on-chain balance. And it looks like my Lightning channel might still be pending. Let's just keep refreshing. Refresh. Oh, something cool I'll show you. You can go to MutinyNet.com, I believe. Yes. And so they have their own mempool. So you can actually see these are all of the blocks going by every 30 seconds. You know, 1 minute ago, 2 minutes ago, 2 minutes ago, 3 minutes ago, 4 minutes ago. So it's pretty cool. So you can visualize everything that's going on in MutinyNet and kind of look up transactions, just like you might before. And I wonder, we could probably find my transaction in this recent transactions list, the channel open. But let's go back and refresh. We should be... Okay, there we go. So now we have inbound and outbound. So our outbound, 80 million sats. Inbound, what is that? 100,000. And actually 800,000 outbound, 100,000 inbound. Cool, so that worked. We now have a channel and we have some on-chain, and we can see Voltage is updated here and shows us our Lightning channels. So great. Now that we have that in place, let's finish building out the rest of our app. Okay, so let's build out our components now. We're gonna have a component for channels, a component for peers, and then one for a Lightning wallet. Okay, so we're gonna create a component folder in a channels.jsx file, and this is part 1. So I'm just gonna copy this code, and don't worry, I'll walk through it. So inside of source, we'll do add folder. We'll call it components. And then inside of that, we'll add a file. We'll call it channels.jsx. Cool. I'll paste in our first bit of code here. And we'll go get the next bit. Copy that all. Save. Okay, cool. So let's read through what's happening here. So this is our channels function, channels component. And so passing in the channels. So remember, we're actually fetching the channels inside of app.jsx. So the channels are getting passed down. We have the host port in the macaroon, which is what we need to talk to our Lightning node further. And then we have the load channels function, so we can actually call that from inside of here. We've got state set aside for a form to open channels. And then we have state set aside for the node pub key and then the funding amount for when we do that, which we'll see what that looks like later. This hex to base 64, this is just an encoding function. We're taking hex. We have to encode it to base 64 for the node pub key. That's just something dumb that we have to do here, but don't worry about that. We've got open channel, which once again, we're pointing to the Lightning docs to show you where you can find that method. And it looks very similar. We're posting this data to open a channel. We request it with the macaroon, of course the host and the port, and we're going to v1 channels. We take our we get our response, and if we have the funding TXID bytes, that's basically how we know that a channel opening has been initiated. So we do that, and then we call load channels, or else we catch an error. Great. So from there, we kind of render our channels UI here. There's going to be a form that you can open, and then a channels table to show the channels. Great. So next, let's continue on. So create a peers.jsx component. So same thing as before. New file. We'll call it peers.jsx. And that's our first bit of code, our second bit of code, and we'll have a third part here as well. Let me know if this format for putting in the code, if this is too confusing for you, because I want to do it to where you have access to the code and that you're able to see me putting it in the same order that you will. And then, of course, there's the completed project as well, but I know it's kind of hard when we're, like, I could write all this code from scratch, but that would make us have a very long workshop. It's better if we just get it down here and explain from a high level what's happening. And then you on your own can have a working app that you can kind of grok and see what you don't understand. And of course, ask me questions for anything you don't understand in here. But yeah, so this is our peers. If you don't know, the concept of peers is basically that before we can open a channel with each other on the Lightning Network, opening a channel is kind of like it's entering this contract, this financial contract. So before we even do that, we actually need to be peered with each other. My node needs to have a connection to your node to where we're talking. JPL, send my regards to Rapex. Yes, I will. He's right around the corner. I'll say what's up. I just met him this morning. Legends from La Crypta coming into Pleb Lab. So that's cool to see. What's up, man? Heck yeah. So yeah, we peer with our nodes. Our nodes need to be able to talk with each other. And so this is just some basic functionality to get that in. So we have state set aside, like always. We have a function to load our current peers. We have a function to add a peer, which we'll do that a little bit later, and I'll show you that process. And then we're just displaying some info around it, showing the form, letting you open the form with this button. And then we have a table to display all of your peers. Sweet. Okay, we're getting close, and then we'll see all this in action, and it'll make some more sense. So next, we're gonna have the Lightning Wallet component, and this will be the final component. So let's copy this first slide here and make a new file, lightning wallet.jsx. Okay, so first bit of code is inside, that's part 1. Part 2, there's gonna be a pay invoice function. We'll paste that in. And then part 3 for Lightning Wallet, and this is the return. Sweet, I'll save that. Give it a little bit of formatting. All right, and here we are once again, We are passing down host port and macaroon. We are passing in lightning balance as well. We set aside state for the form that we have, which is for sending and receiving from our Lightning wallet. We have a function to create an invoice here. Very similar as before. We have options to define where we are calling, what we are calling it with. Pass in our macaroon. We get a response. We set it to the correct state, or we catch an error. And the same thing for paying an invoice. We have an invoice that we should be expecting to pay, and we request, of course, with our admin macaroon, we are able to pay an invoice. Get the response, let the user know the invoice is paid if we have the pre-image, and then set the state accordingly or catch an error. All right, and very similar UI, forms for receive, forms for sending, and a receive and send button. And then we actually also, we show our lightning balance in here as a whole unit, which we haven't done before. Okay, and that is that piece. So that's all of our components now. But now we're gonna have one more, finally, one more bit of code to put in. This will be components.css. So, you know, just to add some styles here. I just realized I'm not importing, might not matter. Let's add file, components.css. Great. And I'll grab the first slide of our styles here. I'll grab the second slide. And there will be one more, part 3, for all of our styles. I know this a lot, but this is styling literally all 3 of our components. Beautiful. So yeah, I mean, this is all, a lot of this is pretty basic CSS. I mean, adding margin, colors, you know, a little bit of border. Nothing too fancy going on here. Yeah, a little bit of hover effects, but mainly just formatting and aligning everything. But okay, so we just added a bunch of code. Let's look at the state of our app now. It should look a lot different. Refresh. We actually need to totally reload this. So let's reload, and we're gonna have to reconnect. So I'll go back to Voltage. I'll grab my API endpoint, https:// We know our port is 8080, and then we'll grab our admin macaroon once more from the macaroon bakery. And remember to copy it as hex. Put that in and connect. Oh, nothing has changed here, of course, because we haven't put our components inside of our return here in app.jsx. So, I'm sorry, this is something I overlooked. Like I said, I put this demo together over the last day. So let me just grab the final return from our app.jsx. I'm just gonna copy this whole thing, and I'll just set this aside right now. Our final app.jsx to finish things off. And I'll put this in. It'll be super, super small, but actually, it's not formatted. Let me paste this into my code editor, and then it'll be formatted. Copy that. Paste it in. And yeah, I know this is a little bit of a ridiculous last slide, but okay, there it is, at least so you have the final code. Let's Let's paste this into here. There we go. So now all that this is really changing is we're importing these components that we just created, and then we are rendering them inside of our return. So right here, connect form, that's what was already there. This was already here. So really all that we added was this. So actually, let's change the slide. We don't need all this garbage. We need the imports. We need the imports plus ... plus the updated return, which starts right here. And I'll just say update imports. Okay, cool. So that's the final bit of code there. And we updated it here. We saved. I can close this out again. Okay, and now let's we don't even need to refresh. Okay, so here's the rest of our UI. Very cool. Okay, so what has happened so far? This is still our Austin node. We've got our on-chain balance that we requested. We have our single channel, which is here at the bottom, that we opened, or we had opened to us, right? So we have a local balance about around 800,000, remote balance of 100,000, and we have the one peer, of course, because we had to be peered with them to have them open a channel to us. And we can see their pub key, address, bytes sent. That's kind of cool. Bytes received. And of course, we have our Lightning wallet here, and so we can send and receive seemingly. And so another link that we can open is Mutiny. It's faucet.mutinynet.com. Let's open it right here. Faucet.mutinynet.com. Okay, it's pulling it up here. And this is just has a bunch of, more ways to get sats sent to you on chain through Lightning, have invoices paid and stuff like that, just to test out MutinyNet. So let's try in our wallet. I'm going to ask to receive some sats. Let's receive 21. And we can create an invoice. And that invoice is right here. I'll copy it. Okay. And let's try and have MutinyNet pay us. So I can put in a bolt 11 request. Strike me now. Paid the invoice. Here's your proof. Sweet. And so if I go back to the wallet again, this should increase by 21 sats. Wait, no, sorry. My Lightning balance should increase. So there we go. Plus 21. Great. So our channel is working. It is live. We are live on the global Mutiny network. Okay, but there's one last thing I wanted to do here, and this is an experiment that might not work. But I already had my Plebdevs node set aside, right? So we're in Austin node, but I'm actually going to go to my first Mutiny node. So we've got two MutinyNet nodes. I'm going to go to this one, Plebdevs. And we're going to open this up in another tab. Sweet. Okay, so I have this. I can just right click on this tab with my app in it and click duplicate. And I'm still connected over here because it's just a front end. It's just a front end that's making calls to some server. It doesn't really know. So I'm going to connect to Plebdevs here now, my Plebdevs node. So I'll copy the API endpoint, https:// there we go. It'll be port 8080, all the same. And then I'll go to my macaroon bakery for this one and grab the hex, admin macaroon, and connect. Cool. Now here's my Plebdevs node. And it's missing. That's weird. It's not showing the rest of the UI. Let's restart our server, actually. Yeah, let's do that. It doesn't seem to have refreshed, refreshed with the updates. So, new tab, another new tab. Okay. So we'll start with Plebdevs this time. So Plebdevs will be this guy right here. Put in the macaroon. Go back home and do this real quick. API endpoint. GPS. And then port 8080. Okay, that looks right. So now we've got Plebdevs right here. And let's jump back over to the other MutinyNet node and connect to that. I think it's very telling that the most confusing part about this workshop has been us putting in the front end code. The Lightning node here and interacting with it has been incredibly easy. It just spins up in 15 minutes. It works. It's free. And we have one of the best Lightning dev environments just right at our fingertips now. So I'm so stoked to keep on using this product. Okay, finally the macaroon for admin. Connect. Okay, so now we are connected to Austin. We are connected to Plebdevs. Let's refresh. They're both at the same block height now. Cool. But these two nodes are not connected. Now I want to see if we can have Austin and Plebdevs open a channel up together. So let's give it a try. So first of all, we're going to need to add a peer. So I'm going to start with Plebdevs here. We'll have Plebdevs do the work. And I need to add a peer. And to add a peer, I need their pub key and their host. Okay, so my pub key for Austin's right here, so I'll just copy that. And then the host will be https://. And let's see, we're opening up to Austin. So I still got that here. So that's our host. And I believe we actually need to specify a port. Do we? I'm trying to think. What is the default? What is the default port for peering? We can find this out. Let's go to Mutiny Faucet. They have an example of like, hey, peer with us. Faucet Lightning node. So they have at host at 9735. Okay, cool. So it's 9735. Um, 9735. So hopefully this should work. Add peer. Message Tor general error. Okay, let's see. Let's go to our node dashboard here. Node public key connection string. The connection string. So you can actually grab it right here. That's even easier. And I guess this is being done over Tor. So we're only peering over Tor. So that's a pretty good thing to do. Okay. So I only need the first part of that. Yeah. Add peer. Peer added successfully. Okay, cool. We can refresh now. And It doesn't seem to be reloading my peers when I refresh. Load peer. Oh, oops. No, I don't want that. Okay, so load peers happens every time our app loads. So we would actually have to reload this whole app. That's kind of annoying. But yeah, we'll do that in a second. We know we're peered, at least. We're just not updating the peer list down here. So another tiny flaw in my project. But I know the channels will update. So now that we're peered, we can open a channel with that peer. So I'm going to grab Austin's pub key again, and we're going to have Plebdevs open a channel to Austin. And we'll do 1, 2, 3, a million sats. Open channel. Let's see, what do we get? Nothing's happening. Oh, channel opening initiated. Okay. So now as I refresh, our channel open hit the mempool. We could probably see it somewhere here. It was a million sats. So maybe this guy. Maybe, is that a channel open? No, that has 48 confirmations. Needs to be recent. Let's see. Refresh. Okay, not there quite yet. We'll see our channels show up. It'll need about 3 to 5 blocks to confirm. So, 30 seconds. That's not too long to wait. Refresh. Okay, we'll give it a few more blocks. Voltage should also show us something. It says active channels too. Let's try again, refresh. Oh, look at that. Our second channel is here. Okay. So we see channel number 2 with 1 million sats as a local balance, or just under 1 million because we had to pay fees, or maybe that's the fee reserve. And then a remote balance of 0. Sweet. So we just spun up 2 MutinyNet nodes in, like, how long has it been? It's been like an hour. We've spun up 2 MutinyNet nodes. We built an app. We were able to connect our app to both of those Mutiny nodes, and then we were able to, through the app, have our 2 Mutiny nodes open a channel to each other. What the heck? So if I refresh over here on Austin, now Austin will have 2 channels. So we're both connected. So let's have Plebdevs pay Austin. So I'll do receive here. Let's receive, screw it, 21,000. Create invoice. Okay. And then we'll have Plebdevs here pay that. Pay this invoice. Give it a second here. Okay, invoice paid successfully. And now if I refresh, our lightning balance went down. And if I refresh over here on Austin, our lightning balance went up. Boom. So we are live with 2 different instances, 1 app on MutinyNet. So that's very cool. So man, I have a few kinks to work out with this little app. Sorry for the small issues here, but the final project is available. All the code that I built it, putting in order, is here. So I hope you find that helpful. And I'll probably come back through and clean up these slides a little bit. But yeah, that all worked. That all worked, and that was extremely easy. Just for reference, like some of my other workshops, it can take 45 minutes to even get our Lightning development environment up and running, and for me to have been able to explain it and everything that we're doing. So this was way easier. And I literally have 2 MutinyNet nodes now. So, oh, this is one last thing I wanted to see. Right here in MutinyNet.com, their mempool, they do have a Lightning tab, and you can see how few nodes there are in the network. I wanted to see if I popped up on the network at all. Felony. No, I'm not up here on the global. Oh, Tor nodes excluded. Okay, so our MutinyNet nodes on Voltage are Tor by default. It's interesting. I wonder if you could edit that. Channels, peers, transactions, monitoring logs. Instructions. My node settings. Skip Tor proxy for non-linear service. When setting is activated, ClearNet services will not use a Tor proxy and will just use ClearNet instead. Okay, so I believe this is probably that setting that you'd want to turn off if you want to just be on ClearNet. But, you know, it'll have to restart our node, so screw that for right now. But yes, we have our completed app. And once again, you know, if you're joining late or something like that, the links for all of it's here. It's also floating on the screen. So, yeah, be sure to check it out. And of course, I will upload this as a YouTube video, and you can watch it after the fact if you missed it live. Okay, so let's do some quick shills before I finish out. So plebdevs.com. This is our very humble and basic website. I promise you, I'm working on something amazing that will blow this out of the water, but this is what we have right now, plebdevs.com. You can link out to our 2 courses, our Plebdevs community on Discord, and of course we have a whole list of workshops here. And actually some of these are old workshops, but this will link you out to the YouTube. But yeah, so if you want to learn how to code, if you want to learn how to build Bitcoin and Lightning apps, this is the place to start. Our Lightning Wallet front-end course, I made this with Super Testnet, and this will walk you through writing your very first code up into the point to where you're going to build a simple Lightning Wallet using HTML, CSS, JavaScript, and React, very similar that we did today. So if all of this code, I know we are moving fast today, if all this code is confusing you, you will learn all of it from scratch from this first course. It's often on sale on Udemy, and of course we sell it for sats on Emeralize. And if you can't afford it, reach out to me. I'll give it to you for free, okay? I promise. If you want to learn how to code, you don't have the money for this, I'll give it to you for free. And then the Lightning Wallet backend course picks up from our front-end course, and you will learn backend from scratch, build a simple Lightning Wallet backend with a server, API, database, and a Lightning node. And we're doing that with Node.js. Right, so these 2 courses right here will take you from pleb to full stack pleb dev. And, you know, and I'm constantly building out new content. And if you go to the YouTube, you go to youtube.com/@plebdevs. And you'll see there's tons of content here. We have tutorials. I have review the Bitcoin halving code, workshops, live coding, talking about developer stories. We're just making more and more content here at Plebdevs, and just really trying to give those of you that want to build Bitcoin and Lightning apps just all the examples and tools that will help you be successful on that journey. And so, okay, so that's my shill. That's Plebdevs. So thank you for joining another workshop, another live stream. I'll be back again on Monday talking through the top devs stories of the week, 4 p.m. CST, so look out for that. And besides that, I mean, we're just going to keep building, keep shipping, and yeah, you know, reach out to me on Twitter. You can find me at Bitcoin Plebdev on Twitter. This is my little guy. Of course, Plebdevs on Twitter as well. And if you're trying to learn how to code, you know, reach out to me for help. I would love to help you out in your journey and give you some advice and stuff like that. And of course, the Discord or Twitter or wherever is a good place to do that. Okay, so enough shilling. Thank you all for watching another Plebdevs workshop. I hope you find MutinyNet and Voltage useful. I highly suggest you look into these tools and invest into them. They will make you just a faster and more effective Lightning developer. But all that being said, cheers, happy Saturday, and I'll see you next time.